Chris.
Okay, good afternoon, everyone. Thanks very much for joining today's webinar on your lunch hour. Thanks to the Pipeline Industry Guild for hosting today's webinar, and today's webinar will be presented by myself. I'm Neil Mackay. I'm a Business Development Manager for Stats Group, and today we are going to be talking about engineered solutions and innovative technologies to solve complex pipeline integrity challenges. So for those of you who don't know Stats, we're a world-leading provider of specialist isolation and intervention services, and we're mostly servicing the global oil and gas industry. And at Stats, we're often approached by our clients looking for bespoke engineered solutions, providing innovative technologies to solve their often complex pipeline integrity challenges. Many of these solutions require a combo of Stats products that are often modified to overcome and address the client's unique system and project circumstances. And today, I'll be going through 3 case histories. First is regarding an ILI slipper tray recovery. Second was the world's first double block and bleed isolation of a carbon dioxide pipeline. And finally, I'll be going through a case history for high temperature steam pipeline isolations. So a major oil and gas operator approached us to develop a solution to remove a 2-ton ILI pig launch slipper tray from a 90-bar, 48-inch high pressure gas transmission pipeline. The slipper tray became lodged in the bend after the SDV as a result of an error made during the ILI tool deployment operations. So what happened was the slipper tray retention lugs were not fitted, and the tray was launched along with the ILI tool into the pipe. So the challenge posed to Stats was to retrieve the tray, which was located about 50 meters into the line. And this is what's very statsy about this project. We were tasked with removing it while the pipeline remained at full pressure and under production flow. So we developed a bespoke grabber tool or gripper tool, which of course was fully rated to the pipeline pressure and service. And we used technology from some of our other products, such as our tethered Technoplug range. We used the deployment system from that and adapted it for this application. We also used technology from our emergency pipeline repair services, product service line, and our clamping solutions. And of course, we drew on our pipeline pigging experience, and all of that was coupled and made possible through our in-house design, manufacture, and testing capability. So firstly, and a crucial part of this project was the trials. The trials, well, from PO until completing the job, this project ran from 2015 to 17, so for 2 years. And intensive trialing and qualification testing in our headquarters, which is in Kintore, just outside Aberdeen. We built a full-scale replica, 50 meters worth of 48-inch pipe to trial this system. And that was very valuable. We gained a lot from that. We did the operation about 3 to 4 times in the yard, and the first time we did it, it took about 23 hours, and that was key information the client was looking for. We made several improvements, and when we actually performed the job in the field, it only took us 7 hours and 40 minutes. We also had to test the lifting operation because the crane on site was very close to the limit for installing the temporary pig trap door and the stuffing box arrangement. We used the same personnel in the trial as we used in field, and that's something that we typically do on all of our projects to maintain continuity and experience, especially with a tool like this, which is bespoke in nature. So next I have an animation which contains some in-field footage. video footage and pictures of how the operation went abroad. So this is the gripper tool. The grabber tool has a couple of hydraulically operated grabbers at the front. They can also rotate 10 degrees left or right, because the slipper tray wasn't necessarily sat at the bottom of the pipe. It was maybe at a bit of an angle. And this tool was pushed on wheels. We didn't have any wheels on the side because we had to negotiate a bar T and we didn't want any hang up. You'll see in the top left there some footage from site with the tool being deployed to the pig trap. And our field personnel were there for about 2 weeks to prepare the tool after international mobilization. The gripper tool was installed into the pig trap, and then we installed the temporary pig trap door and the stuffing box arrangement, which was leak tested. The gripper tool is deployed using stem bars. The stem bars are steel rigid bars that we use to deploy tether technoplug isolation tools. So we have a lot of experience in this. They are housing the hydraulic control lines and electrical control lines, which gives the gripper tool its functionality. And because we had to go about 50 meters, we had several of these connections to make. So stem bars are screwed on. And then we also provided a bespoke external leak testing tool, which leak tested the joints each time the stem bar connections were made up. We then mechanically gripped the outside of the stem bar at special locations, and then it's hydraulically deployed into the pipe with a sort of sliding system at the back. As the gripper tool is deployed into the pipeline, we have wheel assemblies which support the stem bar, the weight of the stem bar, and they're daisy chained together. There was also a camera on the back of the gripper tool, which was there to keep an eye on the condition of the stem bars to make sure there was no buckling or any issues. And you can see from the bottom right just how clear the picture is and how useful that was to manipulate the gripper tool to allow us to grab the slipper tray and confirm that we'd grabbed the slipper tray before removing it. We didn't actually know how much force was going to be required to remove the slipper tray. We had 18-ton capability. If there was any issues at all with the tool while it was in that position outboard of the ESDV, we had a couple of safety systems. We could voluntarily disconnect the stem bar from the gripper tool with a stab connection and recover the stem bar and abandon the gripper tool in the event of a failure. Alternatively, if we just pulled at greater force than 18 tons, there was a weak link there in case the voluntary stab system didn't work. But thankfully, we didn't have to do that. We were able to remove the slipper tray successfully first time. And like I said before, in 7 hours and 40 minutes. So fantastic operation. Needless to say, the client was very happy. And anyone that works in the oil and gas industry will appreciate 7 hours and 40 minutes is not even a full shift. So that was a real, that was the cherry on the cake. So just a couple more pictures of the tool. So here's the slipper tray being removed and a picture of the slipper tray post removal. Just another picture from another perspective. Obviously a lot of eyes on this project, a huge focus on it, but couldn't have gone more smoothly in field. And that's owing to the fact that we did so much pre-testing prior to mobilization. Moving on, the second case history I have for you today was a project we did for Kinder Morgan. They're the largest transporter of carbon dioxide in North America, transporting 1.2 billion cubic feet per day. That comes from both natural and industrial sources, from source fields in southwestern Colorado, travels through New Mexico and on to Texas. It's transported via the Cortez pipeline, which is 30-inch and 500 miles long. And that carbon dioxide is used primarily for tertiary enhanced oil recovery projects. Most of the oil that's produced down there is through such projects, and that allows Kinder Morgan to produce about 52,000 barrels per day. The Cortez pipeline needed to be inspected, needed to be ILI'd, and the existing system just didn't allow that to happen. There was no pigging facilities. Shutdown of the line and interruption of the CO2 transportation was undesirable in order to retrofit these pigging facilities. And Kinder Morgan had been using Stats Group for gas isolations, and we were delighted to be given the contract for the line stopping contract, on this pipeline, due to the advantages of our bicep tool over the traditional line stopping technology. So at several locations, we provided the isolations, and the customer installed the pig launchers and receivers and valves, thus converting the pipeline from a non-piggable line to a piggable line and allowing the ILI to be undertaken. So the Stats system for doing this is the safest and most efficient in the world. The system we used on this pipeline required 4 full-bore hot taps in total, and crucially, no shutdown is required. So the pipeline remains at normal operating temperatures and pressures, and there's no disruption at all to throughput. So now I have another animation for you. And I'll take this opportunity to have a wee drink. Thankfully, I'm not coughing too much today. So the first thing that we need to do is we need to weld on some hot tap fittings, and these are going to provide a 30-inch hot tap to be performed, which is required when we're installing 30-inch biceps, of course. We then install what we call slab valves, which are gate valves. They're dual seal with a monitorable annulus. And then we install the hot tap machines. At Stats, we have our own range of hot tapping machines, which we developed a few years ago. So the pilot drill has a positive retention system, some pins which deploy and capture the coupon. Coupon is recovered, close the slab valves, and that allows us to safely remove the hot tap machine in preparation for installation of the biceps. Bicep stands for branch installed self-energized plug. It's the safest and most efficient pipeline isolation tool deployed via hot tap in the world. The temporary bypass was then installed and commissioned, and with gas flow around the bypass, we were able to deploy the bicep tools. The biceps are hydraulically deployed into the pipe. Heads are then hydraulically rotated into the pipe and away from the section of pipe that we're isolating. And the heads are also contracted hydraulically, which pushes the seals, which are HNBR, up against the ID of the pipe. And these seals are very high spec, and they are good at sealing and pitted and corroded pipe work as well. The second bicep is installed. The isolated section of pipeline can be vented and purged through the bicep tools themselves. There's no requirement for any additional fittings, welded fittings between the biceps. Each of the seals are independently leak tested and verified, and then we have a hold period where we monitor the tool, and that varies from job to job, from customer to customer. But following that process, we sign an isolation certificate, we hand that over to the client, and that essentially tells them it's safe to cut the pipe and perform their works. We also monitor the bicep isolation while it is in place for any pressure build up in the annulus between the two seals. So now we're only flowing around the bypass. Here we show a dent being removed. In reality, pigging facilities were installed. Now, most of the time in the UK, certainly clients perform golden welds, so they don't have to, hydrotest the whole line. But the bicep seals are bidirectional, and they do permit a reverse test against the head. So you can perform a hydrotest of the new welds in between the two biceps, which is another fantastic feature. So at that stage, everything's good to go. The biceps are hydraulically recovered from the pipeline sequentially. The slab valves are closed on the bicep branches, and because now we've got flow through the main line, we can remove the biceps and we can remove the temporary bypass. And then, so that we can remove our slab valves, which are just temporary hot tapping valves, they're not for permanent installation, we use the hot tap machine to deploy a completion plug into the hot tap branch. It's tested, then we can remove the hot tap machine. The whole purpose of this is to remove the slab valve, and then we can terminate it with a blind. And if you reverse that process, you could come back to site, some time later, reintroduce the bicep to get a future isolation. And at least once on this project, that was required because one of the permanent valves that were supplied to the customer from a third party had a manufacturing fault and required to be replaced. So we went back and we put the bicep back in through the same fitting by reversing the completion plug installation process. So the animation makes that all look very straightforward. I don't want to take away from the challenges and the risks of the project. We were delighted to receive an award from the Pipeline Industry Guild. I think it was 2019. We won the Onshore Pipeline Project Award for this project. What was tricky about it? Well, the pipeline pressure, for one, was way up there, 147 bar. The highest operating pressure we can go to with the bicep is 152 bar. And at the temperatures and pressures in the line, the carbon dioxide is actually transported as a liquid. And that had never been done before with a tool like this. So this was the world's first double block and bleed isolation of a liquid CO2 pipeline. The major risks associated with liquid CO2 are the formation of solid CO2, so dry ice, during depressurization and also refilling of what would be the reinstated pipework. And the main concern around dry ice is freezing of the bicep control and monitoring lines, which contain hydraulic fluid. We were obviously also concerned with compromising the seals, which are HNBR. Also, very low temperatures could be experienced during depressurization, in excess of the standard bicep temperature rating of -20 degrees centigrade. And we were also concerned about rapid gas decompression. So that process where supercritical fluids can permeate into materials such as seals at these operational temps and pressures, but once exposed thereafter to ambient conditions can expand aggressively and tear and burst material. So those were the things that we really needed to consider and spend some time on trialing and qualification testing prior to traveling to site. So to address the rapid gas decompression issue, obviously we took some seals and we immersion tested them in liquid CO2 subsequently exposed them to ambient temperature and pressures, and without getting too into the detail, those seals passed those tests. We also selected steel for the application, which was impact tested and rated for -49 degrees centigrade, and it didn't see anything close to that in the field. We performed a small scale bicep trial as well in 12-inch on a section of pipework that was adjacent to the main line. And here you see it on the right-hand side. One of the other things that we had to develop for this job was a dip tube assembly. The dip tube assembly was to avoid the low temperatures that could result from allowing liquid CO2 to boil at low pressure. So this dip tube assembly allowed us to access the 6 o'clock position of the pipe and then discharge and phase change to atmosphere. Operationally, like on any project, there's always a lot of engineering controls. Here's a few of them. So like I said before, the materials we used were good for -49 degrees centigrade, but we ensured that we never went below -20 degrees centigrade. And we had to do that through a staged depressurization when necessary. So yes, it took a little bit longer, but it was worth it for the additional safety. We also purged the annulus void between the two seals on the bicep with N2 to prevent the formation of dry ice in the annulus. And crucially, we provided a positive pressure of N2 during the hot tapping operation and depressurization activities to ensure that no liquid CO2 extended beyond the slab valves and up into the tooling. Also, and finally, to prevent the formation of dry ice during filling of the new pipework, newly reinstated pipework, which you can see here on the right-hand side, we pressurized it with 10 bar of nitrogen, which limited the minimum temperatures to -40 degrees centigrade. And that would have been the coldest that it saw if it saw -40 degrees. So project-wise, we did a lot of hot taps. I think it's fair to say we did a lot of bicep isolations. This resulted in about 200 days of bicep isolations in situ. This meant 400 days or 13,500 personnel hours. And overall, the project was a great success. And I wanted to share this project today because we have several bicep opportunities, and we've been awarded a couple of bicep projects with the gas distribution networks in the UK. And in the next year, we're going to be, I'm sure, presenting these projects at events held by the Pipeline Industry Guild. So watch this space. And some of those projects have very unique challenges that the bicep's been able to solve. And that those challenges have been running for years, and the bicep's been able to solve them because it's very versatile. It can be installed on slopes. It can be installed from up underneath the pipe. And it can be installed on very short sections of pipe because you only need a fitting length of pipe to install a bicep tool. Finally, the last case history I have for you today was a restoration project. It was to rebuild sections of the refinery following a fire, which caused damage and greatly limited refinery production capacity. So what the client required from us was leak-tight pipeline isolation services ranging from 3-inch to 54-inch. And this was for a major refinery in the Middle East. So the scope presented many challenges, and it really pushed the limits of the STAT's current isolation technology. We required further research and development. We're talking about seal qualification, material qualification, and the usual, as you can imagine, testing and trialing. So the steam lines to be isolated were 30-inch, 24-inch, 36-inch, and the temperature ranges were from 190 degrees centigrade to 381 degrees centigrade, and pressure range was from 4 to 42 bar. So with several isolations involved and several hot tapping operations as well. Just to share a couple of pictures of one of them. The reason I like this picture is you can see that the plug has been installed in the 1 o'clock position on the pipe. And as I said before, you could install this coming off at the 3 o'clock or up from underneath the pipe at the 6 o'clock. The tools are really versatile, and they can be installed in very short spaces, which is ideal in refineries. Yes, they're big, bulky, heavy bits of kit, but because you can install them at 1 or 3 or one of the other positions around the pipe, there's usually a way that you can get these tools in. And here is a picture of a 54-inch hot tap. So our capability goes up to 56-inch now. That's same for our hot tapping services as well as our plug services. But here, nice picture of one of the jobs in the field. And with that, I will finish, and I will ask if there's any questions. Have any questions come in? If so, I'd be delighted to do my best and try and answer them.
Thank you very much, Neil, for that very detailed and informative presentation, covering quite a broad range of different applications there. If anyone from today's session, attendees from today's session, would like to ask any questions, either type them in the group chat or alternatively feel free to unmute and ask them yourselves. Neil, just an outline question here. The bicep tooling that has been used, what independent certification or verification does that tooling carry?
Yeah, thanks for your question, Aidan. So the tool is very high spec. It's DNV type approved from 3-inch to 56-inch. And that type approval extends to the remote techno plug, which you can see here on the screen as well. And that's something we're very proud of. And it just gives our clients a certain level of confidence that they can order a tool within that range, and with an independent project-specific factory acceptance test, qualify the tool for their own system.
Great. And I guess in addition to that, you showed two very different extremes of application there, from CO2 to high temperature steam. What is the range really of applications that the technology can be used within?
Yeah, so we've used it in oil and in gas. Obviously, that's the most common uses of the tool. We were the first company to do anything like this in liquid CO2, and there's a huge focus just now. There's so much content on hydrogen out there. We haven't yet done it in hydrogen because we haven't had the requirement yet to do it in hydrogen, but we're working on with several other parties right now on welding qualifications for split tees to hydrogen pipelines. So we know that's coming. We're working on the pre stuff to that. The welding of the fittings on the line is the first thing you have to do. And we're really excited about hydrogen and the plans for hydrogen. I'm sure the bicep one day will be in a hydrogen pipeline isolating, and we can do another presentation to the Pipeline Industry Guild. Also, in addition, in terms of temperature, Aidan, we've also proved through tests and trials that we can use the bicep with the correct material specification to isolate in extremely cold pipelines down to minus 170 degrees centigrade. That hasn't again cropped up yet, but that's been proven in the yard. So we're just looking forward to that challenge when it comes up.
Okay, thank you. I guess if anyone of our attendees today have any questions, feel free to raise your hand through. Can you raise your hand through Zoom, or ask any questions in the chat box? Feel free to also unmute and ask directly. So a question here from Nathan Brown. Was there an assessment for the thrust restraint when taking a section of pipe out between the hot taps? Is this something that is made redundant with the weight of fittings?
Yeah, it's a good question. It's a good question, Nathan. Thanks. It's not stat scope work usually to look at that, but I'm sure the client investigates that. And we've done another project at Stats where there was a thermal buckle on a pipe, and there was a lot of stress in the pipe, and we developed a system to actually grip it and hold it in position while we isolated it, and then the client cut the section of pipe out. So we can develop systems to control that behavior, but on this project that's not something that it was part of our remit, so I can't comment too much on that, unfortunately. Sorry.
Look, I guess if there's any other questions at the moment, feel free to send them in. Other than that, I'm sure there'll be Neil's contact details will be available after this presentation today, and any others, feel free to get in contact with him directly. Thank you again.
Thanks. Yeah, thanks, Aidan, and thanks to the Pipeline Industry Guild as well for hosting the webinar. I think we'll pass over now to Catherine, who's got some final remarks.
Yes, thanks Neil and Aidan, and to everyone for joining today. Just to remind you that this session has been recorded and we will upload it to the YouTube channel in the next few days. And looking forward to our future events and webinars, can we just remind you to check out the Guild's event calendar on our website. We've got our Eastern Branch lunch, which is our, well, we had some karting this week, but the Eastern Branch lunch will be our first sort of social event with speakers on the 29th of October. Then the 2nd of December, we have the Prestige Lecture with Colin Skellett, who's the Chief Exec of Wessex Water, which is taking place in Bath ahead of the 50th Wales and West Branch dinner. And then the big one is the Guild Annual Dinner, which is on the 8th of March at the Grosvenor House in London. And there's still sponsorship opportunities and tickets available for that. Get in touch with Kate at Guild HQ on the events at pipeguild.com email address if you're interested in that. So thanks again to everyone, and have a good afternoon.
Thank you. Good afternoon, everyone.